Okay, welcome to lesson 8.3. This is the third lesson in grade 7 on geometry, and in this particular lesson we're going to concentrate on what's called perpendicular bisectors. And in order to do perpendicular bisectors, one of the things we have to be able to use is a Myra. So let's go back and take a look at just how Myras work and why they can, what they actually show you. So if you take a look on the right on here on page 306 in your textbook, you'll see that there's a rhombus here. Right, there's your rhombus. Now I've drawn an angle, a line right across here. Now my drawing is not the way they did theirs. They drew their rhombus was slightly different. They had theirs looking, I guess, like this here, right? So I just turned mine so that it works for me, right? Because I have to do some switches here. So this is all I've done is just changed my rhombus to be like this, right? So having done that, let's get rid of this thing. Now, if you recall, this is a rhombus because it has 4 equal sides here. And you'll see they got the tick marks here, these prime marks. And that tells you that this length from here to here, and from here to here, and from here to here, and from here to here are all equal. This is a square that's kind of been rocked over to the side so that the angles are no longer 90 degrees. Now, this rhombus, if you divide it in half right here with this line, this will show you 2 triangles. Now, these triangles are called isosceles triangles because they have an equal side here and an equal side here. And if you remember back, the types of triangles there's a equilateral triangle which has all 3 equal. There's an isosceles triangle that has 2 equal. And of course, the scalene triangle where all 3 sides of triangles are different. So how do I know that this is an isosceles triangle? Well, because I have 2 equal sides. Now, in a rhombus, if everything's drawn correctly, and I cut it right across here, this triangle here and this triangle here are what we call congruent. Now, congruent means that they are exact copies of each other. Now, when I move this one out here and move this one out here, we have to try to prove how this is possible. Well, the easiest way for me to do it is to grab it and then just do what's called a vertical flip here. I'll flip it up, down, and then I can just move it up and put it in place, and you can see that, well, a little bit of moving there. These are exactly the same. So this top isosceles triangle is congruent with the bottom one. Now that means that this line right here is called the bisector. It cuts it in half and both sides are equal. Now this is also referred to as a reflection line, and it's also called a line of symmetry. Those are terms you've heard in the past. Okay, so what makes this an isosceles triangle? It's when you have 2 equal sides. And is there any on this diagram? Yes, we know that there's 2. So what is true about these two isosceles triangles? Now, the 2 isosceles triangles we were talking about are these 2 right here. And we know that they are exactly congruent. Okay? Now, how could I prove that these are congruent? Well, the easiest way would probably be to fold it in half right on this line and see if this one would match up with that one. So that would be your fold line right here. The other way I could do it is I could take, so that's folding across line of symmetry. The other one would be to use a Myra and to put your Myra across here and look through it and see if it matches perfectly. And of course, the last one, I could take up my protractors and my rulers and I could measure every angle and every side. Okay? Now, those are the ways that you can do that. Now, if you were in my classroom, I would show you how to use a Myra at this time. And to help you out, if you do have a Myra, this is what you're going to do. We want to know, is this triangle here, is it congruent to this triangle there? Now, to do that, you have to take your Myra, and you're going to have to take and turn it, and you have to put it right on that line right there. And depending on which side you look through, if you look through from this side, you'll be able to see the shadow of the top line on top of this line here. Now, if everything's placed correctly and it matches perfectly, then this triangle up top and this triangle down here are what we call congruent. Okay? Now, to do the one down here, same thing. Only now my line is not going sideways. My line is now up and down. So doing the same thing here, put this on this, and as you look from the right or left, you'll see the other shape on the other side. Now that means that this one here is congruent to this one here. This is a bisector. That line that we have right here, it was drawn here. This bisects this shape into 2 congruent halves. This is also a bisector. It divides this one into 2 congruent halves. Now, let's go on to what we're going to be doing. I want you to get a piece of paper out, and with your ruler, I want you to try to draw a perfectly symmetrical object. Okay? Now try to stay away from squares and triangles and rectangles. So try to find something unique. So pause the recording and see if you can do it. Okay, now this is how you can check. If you have a Myra, you can put your Myra on here and look through, and if you get this shape on the other side perfectly, then you've got a symmetrical object, and it's perfect, okay? If you don't see it, then it's not symmetrical. Now this right here is what we call a bisector. It cuts this star into two equal and congruent halves. Now, we're going to now go into what's called bisecting a line. Before we bisect shapes and stuff, we have to know how to cut a line in half. Now, to do that, we have to go over some terminology. When you draw a line to divide line segments into two equal parts, now instead of, like I said, instead of having two equal shapes or congruent triangles, we're just going to start with just two equal lines on either side. It's called bisecting. Now, bisecting, bi means two, and secting means to separate. So by separating it into two. The line is called the bisector. So this is a bisector here, because A to here and B to here are equal, and it's shown by two vertical tick marks. Over here, this is also a bisector, and that means from A to here and B to here are also the exact same lengths. So this one also bisects it in half. Now, this is the line segment from A to B. You notice it's drawn, it has an ending. You put A on one side and B on the other side. So you're going to be asked to draw line segment AB, and that's what you're going to have to draw. That line, put A on one end, B on the other. If it tells you how long to do it, you have to make sure that it's, the length that they give you, 10 centimeters or whatever, okay? Now, there are two types of bisectors. Ones which divide them in half. This is just called the bisector. And you'll notice there's a difference between this bisector here and this bisector there, okay? This is slanted, and this is straight up and down. And you notice a little box there, that means 90 degrees. So bisectors which are at 90 degrees or perpendicular, they're called perpendicular bisectors, oddly enough. So these are the two types of bisectors we work with. This is just straight bisector, and this is a perpendicular bisector. So what you're going to be doing in the next couple of pages is we're going to get you to do a perpendicular bisector on a line and in a variety of different ways. So here's the first way we can do it. On a piece of paper, I want you to draw and draw and label A, B, just like they've done right here. All right. Now draw it fairly thick so you can see through the paper. Okay, so do that right now. All right, now that you have it done, I want you to fold the papers till this point right here for A and this point right over here are on top of each other, and then fold the paper and you'll get a crease in the paper. All right. Now that crease is your bisecting line. Now I don't know if I can make this actually do it, but this here is where your line bisects. So that's your perpendicular bisector. So this would actually be a 90-degree angle right here, and on that side also. All right, now, if you have a Myra, you can do the same thing. Draw a line, just like you did right here, AB, but put your Myra on it like this, and as you want to line up through the Myra, the A and the B points exactly on each other. Once you have that, you draw a line here, right along that little indent on the bottom of the Myra. You join the dots, and what you'll have when you're finished is a perpendicular bisector. So what I'd like you to do is I'd like you to try both of them, all right, if you have a Myra. So doing this one, draw a perpendicular line by folding the paper. I'm going to give you two letters here to work with. We'll call this B, and we'll call this C. So I want you to draw a line segment BC, and I want you to make it about 10 centimeters long, and then I want you to fold the paper in such a way as to get a perpendicular bisector. So you go ahead and do that. All right, now you should have had no trouble doing that. When you fold the bisector, you're going to get the crease of your paper should be exactly 90 degrees right down the middle. And that will mean that this side over here and this side here are equal. And if you measure from B to the line of the symmetry, or here to the line of symmetry, which is also your bisector, you will find that this length and this length are equal. And if you were to take a point here and measure down to there, and a point here on the bisector and measure to there, you would find that this line here and this line here are also equal. And if you did it from here, and again out to there, you'd find this one and this one are equal. In fact, it doesn't matter where on this line you measure, you will find that every time you do this measurement, the outside line here, the one that connects the point on the bisecting line to the point C and the point in the bisecting line to the point B, these two lines will always be equal. If at any time this line and this line are not equal, that means that your bisector is not 90 degrees. It's not perpendicular. All right? Now going to the next one, and I want you to try it with a Myra if you have one, okay? So I'm not going to wait for this. You can pause the recording if you have a Myra, but I'm assuming because you're at home you don't have one. So what you would do is take your Myra, and sorry, I don't want that. Grab a line here. You put your Myra up like this. I'm doing this really roughly. Right, and as you look through it, you want to take this point here and this point here and line them up, and your Myra will be moved forward and back like this until you get exactly in the middle, and then you take your line and you go right down the side of your Myra like that, and when you're done, you can take your Myra out of the way. I don't suggest you break it into pieces like mine. Okay, take your Myra off. I guess I got that wrong one there. Oh, it doesn't matter. Okay, when you take this off, this will be your perpendicular line. It'll be 90 degrees. Now, in order to show it's perpendicular, I want you to always put the little perpendicular box in on all of your lines here, which are perpendicular. Okay, so this tells you, or tells the person looking at it, that this is a 90-degree angle, and it is required. Okay, so we've done folding, we've done the perpendicular line using a Myra. Now, what's left is to continue on using a couple of other methods. This is called using a ruler, and it's not that difficult, except that people get messed up a little bit with how to place the ruler. Now, I want you to look very carefully at this. You'll notice that at this point B, that's where the top of the ruler is, all right? And you'll notice that this point right here, A, that's got the bottom of the ruler on it. And you'll notice they've drawn a line here and a line from here right to here, and they've drawn another line from A this way. So that's what it would look like first. Now what they're going to do is they're going to take the ruler and they're going to reverse it. And see how this is on the top? They're going to take and put the ruler in such a way that this point here is now down on the bottom. See that? It's now down at the bottom. And they're going to take this part of the ruler and drag it down, and they're going to form kind of like an X, right? This is at the top, this is at the bottom, and now they're going to take their line and they're going to go this way, and they're going to go this way, right? Now when you're finished that, it should look like this. Now the last thing is just to take this point right here where it joins the two ruler tops and then the bottoms, and all you have to do is draw a line down there, and then you should get a perfect perpendicular bisector. And you put in your little square box there. So that's using a ruler. If you have any trouble, just try it, okay? Now I'm going to do one for you just to show you. So the first thing I need to do is move my ruler into place, and then I'm going to take and I'm going to move this end down. And it takes me on the computer a little bit of time because it's kind of hard, but you can see I've got it set up there. And now I'm going to take my line, and I'll take my line here. I'll grab a different color just for, right? And this is what I have, and I can't do this perfectly with the computer, but I can move this in so it's in the right spot. So there's my line going down my ruler. I also have to take a line and have to draw it down this side of the ruler. Now, I've got the first top and bottom done, and now, like I said, make an X. Move this up. Move this up, move this. Okay, I guess it's not going to make you do it that way. Make your X like this. Okay, now put the top of the ruler here and move this up until the bottom of that ruler is there. And now grab your line. There you go. And again on the bottom of the ruler this time. Oops, I'm a little bit off. Slide it up there so it fits perfectly. And then you can remove your ruler. And you'll notice that's still those two double X's. Okay, now take your ruler and turn it vertical now and bring it in, and you want to take and join these two intersections right there. So if I did it right and nothing is incorrect, I should get a perfect perpendicular bisector of the black line there. And of course I have to then put in my little shape here, which tells me that it is a 90-degree angle. Right? If you have any trouble, I want you to go over it and over it and over it until you can do this, because all I'm going to be asking you is the instructions are going to say something like this. Draw a line segment. See if I can find it. Draw a line segment, label it AB, place the ruler on, and it'll say from this point, it'll say draw a perpendicular bisector using a ruler only. And when you show it to me, you should show me a diagram that looks like that. Okay, the next one is drawing a perpendicular bisector using circles. Okay, now the circle, first off, you're going to do is here's your line again, AB. Now you put your compass on here and you draw a circle. Then you go to this point and you draw another circle, and now you've got the two eyeballs looking at you. All right, so we have one here and one here. Now you notice the cross here and the cross there. If you look back a second ago, you'll notice that's what we had here and here, didn't we? So all you have to do now is take and draw a line down the middle of it, which is going to look like this. So there is your perpendicular bisector, and if you grab your perpendicular little box there, that means that this and this are 90 degrees. All right. Now, some people don't put all of this part of the circle in because they know they only need this intersection and this intersection. So if you don't feel like putting the whole circle in, that's okay. You don't have to put this part in. You can just have what would basically look, this part right there is all your, I guess we got to be to the A and the B there, but you want to have the A and the B, and this is the only part you have to be important to worry about. Okay, so you can also take and join this into a rhombus. In one of your text questions that asks you to do this, you just take and draw this to here, and this to here, and this to here, and this to here, and guess what? This and this and this and this are all equal, just like a normal rhombus. So that's how you turn it into a rhombus. Join A to the points there. All right. Now, use your Myra. You can check it. Our next one is to now do creating a bisector through a point above the line. Now, I know I'm going quickly because this is a video. If you have any trouble, stop the video and go back and watch it again. So in order to draw a line, a bisector, and remember this is not going to be a bisector really. This is going to be a perpendicular line because unless this C is perfectly halfway between A and B, it's just going to be a line. Okay, so I probably should have changed this word here just to say a perpendicular line. But anyway, this is how you do it. You take and put your compass on C. You stretch your compass out till it's below the line, and you're going to make an arc underneath. When you're done, it should look like this. And there's the radius of your circle. That's how far out your compass is stretched. So when you're done, you'll have the line, the dot, and a smile. Once that's done, we now have to take and do, and this looks complicated, but we'll go through it, okay? Take the compass, put it on here, and you draw yourself a circle, or just the part that you need. All right, put the compass over here, don't change the radius of the compass, and make another line. You can make the full circle if you want. Now, you know, here's your crosses that we had before, there and there. So now all you need to do is take a line, and if you go and do it right, and everything is perfect, you should see that as I go directly through that line right there, I come directly through the two intersections. And there's my perpendicular line through the point. Okay? All right, now, if this was halfway exactly, it would be a perpendicular bisector. But this is what I was talking about, not using all of the parts that of the whole circle and everything. This makes this here look may or may not be what you want to do. But I'm going to do this a couple times for you just to show you what's happening. So here we go. We're going to grab this. Oh, do I actually have one? No, I don't. Okay. Let's grab a line. Here's my line, AB. And I have to put a point up top, so I'll just grab this, and I'll put a point. This time I'll put it right there. Okay, this is what you're going to get in your assignment. It's going to be a line and a point. It'll probably tell you draw a line AB, 10 centimeters long, which means from here to here is 10 centimeters, line segment, and a point above it. Now I'm just going to lock everything down here so it doesn't move on me. And now, in order to make this happen, my first thing I need to do is to grab my compass. So here's my compass. I'm going to put the compass point on this. So I'm going to move this around so I get access to it. So put your compass on that, grab this, spread it out, and you want to be below the circle. Once that's done, just make your smile. All right? Now, take your compass, move it over here, and then you can draw a circle if you want, and then move it over to this intersection here, draw another circle. Okay? If you did it correctly, you should be able to go from here straight down, and you'll have your bisector. All right? If this was equal, or you'll have just a perpendicular line. So in this case, I have a perpendicular line. Now, how do you draw one when it's in the middle and the point is on the line? So the draw line segment and place the point in the middle of the line. We're not going to worry about that just yet. We're just going to do a you may not be able to put this perfectly in place. So this is just going to be a perpendicular line through a point on the line. So place your compass on point C and draw an arc on both sides. So here you can put your compass here, and you're going to make an arc here and arc over here. It doesn't matter how far out you go, but you might want to keep it, about 4 or 5 centimeters away so it makes it easier. Now once you have this, you put your compass here, and you can draw the full circle. Put your compass here, you can draw the full circle, and then you have your intersection here and your intersection here. So the last thing you need to do is just to take and put a line straight down. Now if you want to draw the full circles, that's fine. I only draw the intersections because I know that's the only parts that I need. It makes it a little bit easier. So let me do that one for you. We have a line, and we have a point on the line this time. Kind of messy. I'm going to grab this, lock it all down so it doesn't move on me. All right, grabbing my wonderful compass. Again, I'm going to spread this out a little bit. I have to put this here. Now you spread this out so that it's in the right spot. Draw your arc here. Okay, and then of course if you want to, you can just make your smile. If you want to go all around, you can. All right. Now then you move this to here. Okay. I like to spread it out a little bit more, but it's up to you. And here is your first circle, and then do the same thing on this side. All right, now I can get rid of this. You don't need it anymore. And then, of course, all you need to do is locate this intersection and this intersection and go straight down. And if you did it correctly and measured with a proper ruler, that's what you would have. And again, here we have a perpendicular bisector. Now, if I'm marking this and you had instructions on how to do it, it would probably be something like this. Draw a line segment AB 10 centimeters long. Now, what's going to happen here is it 10 centimeters long? Check. Is it labeled AB? Check. Now it says draw a perpendicular line through this. So what I'm looking for is, did you make your smile? If you made your smile on the bottom half, so you could locate this point and this point, they're the important parts that you need, then I'll know that you did it correctly. And then the next thing would be to put your compass here and make your circle, and then make your circle on the end at this point. If you did that, you get a mark. And then, of course, did you put your bisector in correctly? So a question like this could be worth anywhere from 4 to 5 marks, depending on your instructions. Sometimes I just give you an overall 3 mark, and I give you 3 out of 3 because you either know how to do this or you don't. Okay, we'll see how that goes. Anyway, if you have any questions, you come and talk to me. Oh, I guess I do have extras here, but we're not going to worry about it. So, okay, so let's go back here. I won't worry about doing that part. Let's just go down and get you started on your assignment, page 308, 1, 2, 3, 4, 5, 6, and 8. Don't do question 7. All right, if you have any questions, come and talk to me. Other than that, we'll see you in our next lesson.